Assalamu alaikum, this is Yasin Rajput, and today we will be learning about an important concept in redox chemistry: oxidizing agent and reducing agent. These are the substances that either gain or lose electrons during a chemical reaction, and they play a crucial role in oxidation reduction process. So, what are the core concepts before studying oxidizing and reducing agent topic? So, the core concept is you need to understand what is meant by oxidation reduction in terms of electron, in terms of hydrogen, and in terms of oxygen. So, oxidation means loss of electron, and reduction means gain of electron. Oxidation means loss of hydrogen, and reduction means gain of hydrogen. Oxidation means gain of oxygen, that I have taught you already, and reduction means loss of oxygen. And there is another definition, which is whenever there is increase in oxidation number, we can say that there is oxidation, and whenever there is decrease in oxidation number, then we can say that reduction is happening. Okay, so let's talk about the oxidizing agent and reducing agent. This is basically a mnemonic for the oxidation reduction. So you need to understand that LEO means loss of electron means oxidation, and gain of electron means reduction. What is oxidizing agent? Agent makes something happen that cannot happen on its own. So we can say that oxidizing agent makes oxidation happen. Oxidizing agent makes oxidation happen. Or we can say that oxidizing agent oxidizes other and reduces itself and reduces itself. Okay, for example, we have, let's say, this X is an oxidizing agent, this X is an oxidizing agent, and this Y, this X, if this X is the oxidizing agent, so this X actually oxidizes this Y species. Okay, since the name of this X is oxidizing agent, so Y is being oxidized right now and X is being reduced. Okay, so I'm going to repeat it again, that if X is oxidizing agent, then it oxidizes Y and reduces itself. So oxidizing agent oxidizes other substance and reduces itself. Now let's talk about the reducing agent. So reducing agent makes reduction happen. Reducing agent makes reduction happen. Okay, or we can say that reducing agent reduces other substance and oxidizes itself Okay, now this is the example. Let's say this copper oxide is basically losing its oxygen. Okay, so loss of oxygen is called reduction in terms of oxygen. Basically, loss of oxygen is called reduction, and gain of oxygen is called oxidation. So you can see over here that the copper oxide is basically losing its oxygen, and hydrogen is going to accept its oxygen. And you can see in the products that now copper oxide becomes copper and hydrogen gas becomes water. Okay, so copper oxide is being reduced and hydrogen is being oxidized. Now we need to decide that which species or which substance is basically oxidizing agent and which substance is reducing agent. Since this copper oxide is basically oxidizes other substance, this copper oxide oxidizes other substance, so we can say that this copper oxide is the oxidizing agent. This copper oxide is the oxidizing agent. Okay, and you can see over here that this hydrogen is basically reduces copper oxide, so this hydrogen is reducing agent. Clear? And now let's talk about the tricks for the past paper. First of all, you need to identify which substance is being oxidized and which substance is being reduced. So copper oxide is losing its oxygen, so it is being reduced. So you need to just write down R. And then hydrogen is being oxidized. Since you can see that the hydrogen is basically gaining this oxygen and it becomes water. So gain of oxygen is called oxidation. So you just need to write down O. So if you write down R, then you need to write down OA. And if this is being oxidized, then you need to write down RA. So this is the trick to solve the questions. Now I'm going to repeat it again, and you can confirm this thing that if copper oxide is the oxidizing agent, so this oxidizes other. You can see that copper oxide oxidizes other and reduces itself. So according to definition, we can say that this copper oxide is the oxidizing agent. And this hydrogen is the reducing agent. You can see that why this is the reducing agent, because this hydrogen reduces copper oxide and oxidizes itself. So we can say that this is the reducing agent. Clear? And you need to learn by heart some important examples for the oxidizing and reducing agent. So I'm going to write down over here that the potassium manganate, KMnO4, potassium manganate is the oxidizing agent. Potassium manganate is the oxidizing agent, okay? For IGCSE or for GCSE, you just need to learn by heart these examples. Potassium manganate. Potassium dichromate is the oxidizing agent. This is potassium dichromate, and this is the potassium manganate. So these are the examples that you need to learn by heart. Now let's talk about the reducing agent. So copper oxide is the reducing agent. You need to learn by heart carbon oxide is the reducing agent. This carbon oxide is the reducing agent, okay? So basically this reducing agent you will use in the extraction of iron, okay? So you just need to learn by heart for IGCSE or GCSE course. And potassium iodide is the reducing agent. Potassium iodide is the reducing agent. Okay, so these are the two examples for the reducing agent, and these are the two examples for the oxidizing agent that you need to learn by heart for this course. Okay, so that you can solve the past paper questions easily. In this lecture, you will learn how to identify the oxidizing agent and reducing agent, but you just need to watch my video, rules for the oxidation number. If you don't know how to find out the oxidation number, you are not able to understand this. So let's talk about this. You can see over here that the zinc is the element by itself, so it has 0 oxidation number. I'm going to write down over here. Copper has +2, sulfate has -2, +2, -2, and then 0. Okay. So you can see over here that the zinc changing its oxidation number from 0 to +2. So there is increase in oxidation number, and increase in oxidation number means oxidation. And copper is changing its oxidation number from +2 to 0. So there is decrease in oxidation number means reduction. Okay. So zinc is oxidizing. Okay, zinc is being oxidized, so I'm going to write down O, and let's use the trick. And copper sulfate is being reduced, so you use the R. So if this is O, then this must be RA, and if this is R, then this must be OA. This is the trick. You can easily identify the oxidizing agent, reducing agent. Or you can simply look at it that the zinc reduces copper sulfate. If zinc reduces the other substance, so definitely it is the reducing agent. If copper sulfate oxidizes other substance, then it must be oxidizing agent. Now let's look at this. Sodium has 0 charge, chlorine has 0, +1, -1. So sodium 0 to +1, chlorine 0 to -1. There is increase in oxidation number. It means that it is being oxidized and it is being reduced. Why it is being reduced? Because there is decrease in oxidation number. You can see over here that oxidation number decreases 0 to -1. So if sodium is being oxidized and chlorine is being reduced, then it is the reducing agent and it is the oxidizing agent. If you just write on O, then you just simply write on Ra. If you identify that the chlorine is being reduced, then it must be oxidizing agent. So you just need to write on OA. Okay, so aluminum has zero charge, oxygen has zero. In this case, aluminum has +3, it has -2 because oxygen has -2, aluminum has +3. Okay, so overall charge over here is +3 times 2 is +6, and over here that -2 times 3 is -6. So +6 -6 equals to 0. Okay, now aluminum is being oxidized because aluminum is changing its oxidation number from 0 to +3. So it means that oxidation number increasing. It means that oxidation is happening over here, and oxygen is changing its oxidation number from 0 to -2. Okay, so there is a decrease in oxidation number. It means that it is being reduced. So it is being oxidized, it is being reduced. If it is oxidized, it is the reducing agent. If it is reduced, it is the oxidizing agent. Okay, let's talk about the other example. Okay, so in this case, copper has +2 charge, and it has -2, it has +1, it has -1, and it has -1, so it must be +1. Or you can simply find out if you don't know how to find out. Let me tell you this, that copper, we don't know the oxidation number of copper, so I'm going to write on X, but we know that the iodine belongs to group number 7, so it has -1 charge equals to 0 because the neutral compound has 0 charge overall. So X -1 equals to 0, X equals to 1. So you can see it has +1 charge, it has -1, it has 0 because this is element by itself. Okay, let's find out. So copper is being reduced. You can see over here that the oxidation number decreases. Decrease in oxidation number means reduction. Okay, and the iodide ion has -1 charge, and over here iodine has 0 charge, so oxidation number increases, means oxidation. Okay, so if this copper sulfate is being reduced itself, so it must be oxidizing agent, and if this potassium iodide is oxidized, so it must be reducing agent. This is the trick. Okay, now let's talk about the other example. This iron has +3 charge, this oxygen has -2, this has +2, -2, 0, +4, and -2. One oxygen has -2 charge, altogether two oxygen has -4 charge. Okay, again, if you don't know how to find out the oxidation number, you have to watch my video, and that video is basically rules for oxidation number. Okay, so +3 to 0 and +2 to +4. So increase in oxidation number means oxidation. Okay, and decrease in oxidation number means reduction. Okay, so this is being reduced and this is being oxidized. Reduce means oxidizing agent, O means reducing agent. So iron oxide is the oxidizing agent. Why? Because it oxidizes other. It is reducing agent because it reduces other. Okay.